Passes for referring to an item in the module tree. Passes for referring to an item in the module tree. To show Rust where to find an item in a module tree, we use a path in the same way we use a path when navigating a file system. To call a function, we need to know its path. To show Rust where to find an item in a module tree, we use a path in the same way we use a path when navigating a file system. To call a function, we need to know its path. A path can take two forms. An absolute path is the full path starting from a create root. An absolute path is the full path starting from a create root. An absolute path is a full path starting from a create root. An absolute path is the full path. It's a full path starting from a create root. Okay, so for code from an external crate, for the code from an external crate, the absolute path begins with the crate name. The absolute path begins with the crate name. Okay, and for code from the current crate, it starts with the literal crate. Okay. A relative path starts from the current module and use self, super, or an identifier in the current module. Both absolute and relative paths are followed by one or more identifiers separated by double colons. Returning to listing 7-1, say we want to call the add to waitlist function. This is the same as asking what's the path of the add to waitlist function. Listing 7-3 contains listing 7-1 with some of the modules and functions removed. We will show two ways to call the add to waitlist function from a new function eat@restaurant defined in the create root. We will show two ways to call the add to waitlist function. We will show two ways to call the add to waitlist. Two ways. Okay, to call the add to waitlist function from a new function eat@restaurant defined in the create root. These passes are correct. But there's another problem remaining that will prevent this example from compiling as is. We will explain why in a bit. The eat@restaurant function is a part of our library creates public API. Function is part of our library creates a public API. So we mark it with the pub keyword. In the exposing passes with the pub keyword section, we will go into more detail about pub. File name srclib.rs, front of house and hosting, and add to waitlist function, and then eat@restaurant. Eat@restaurant is a function, and then absolute path create front of house, hosting, add to waitlist, and absolute path, and then related path front of house, hosting, add to waitlist. The first time we call the add to waitlist function in eat@restaurant, we use an absolute path. The add to waitlist function is defined in the same crate as eat@restaurant, which means the add to waitlist function is defined in the same crate as eat@restaurant, which means we can use the crate keyword to start an absolute path. We then include each of the successive modules until we make our way to add to waitlist. You can imagine a file system with the same structure. We specify the path. Front of house, hosting, add to waitlist to run to add to waitlist program. Using the crate name to start from the crate root is like using / to start from the file system root in your shell. Second, the first time we call add to waitlist function in eat at restaurant, we use an absolute pass. The add to waitlist function is defined the same create as which means we can use the create keyword to start as an absolute pass. We can include each of we then include each of the successor modules until we make our way to okay. You can imagine file hashes and the same structure. We specify the path to run the add to waitlist program using the create name to start from the create root. It's like using / to start from the file system root in your shell. The second time we call add to waitlist in eat at restaurant, we use a related path. The path starts with the front of house, the name of the module defined at the same level of the module tree as eat at restaurant. Here the file system equivalent would be using the path. Front of a house hosting add to waitlist starting with a module name means that the path is relative. Starting with a module name. Starting with a module name. Starting with a module name means that the path is relative. Starting with a module name. Starting with a module name. Starting with a module name means that the path is relative. Starting with a module name. Starting with a module name. Starting with the module name means the path is relative. Okay. So this the second time we call add to waitlist in an eat at restaurant, we use a related path. The path starts with the front of a house, the name of the module defined at the same level of the module tree as the eat at restaurant. Here the file system equivalent would be using the path. Blah blah blah. Use a related path source. The module defined at the same level of the module tree. Here the function okay. So choosing whether to use a relative or absolute path is a decision you will make based on your project and depends on whether you are more likely to move them definition code separately from or together with the code that uses the item. Choosing whether to use a relative or absolute path. Choosing whether to use a relative or absolute path is a decision you will make based on your project. Choosing whether to use a relative or absolute path. Choosing whether to use a relative or absolute path. Choosing whether to use a relative or absolute path is a decision you will make based on your project. Okay, and it depends on whether you are more likely to move. And on whether you are more likely to move item definition code separately from or together with the code that uses item. For example, if we move the front of a house module and the eat at restaurant function into a module named customer experience, we don't need to update the absolute path to add to waitlist. But the related path would still be valid. However, if we move the eat at restaurant function separately into a module named dining, the absolute path to the add to waitlist call would stay the same, but the related path would need to be updated. Our preference in general is to specify absolute paths because it's more likely we will wanna move code definitions and item calls independently of each other. The error messages say the module hosting is private. In other words, we have the correct paths for the hosting module and the add to waitlist function, but Rust won't let us use them because it doesn't have access to the private sections. In Rust, all items, functions, methods, structures, enums, modules, and constants are private to parent modules by default. If you want to make an item like a function or structure private, you put it in a module. The error message says that the module hosting is private. In other words, we have the correct passage for the hosting module and the waitlist function, but Rust won't let us use them because it doesn't have access to the private actions in Rust. Makes sense. Okay. Create fort of a house hosting and the waitlist. Makes sense. Items in a parent module can't use the private items inside child modules. Items in a parent module cannot use the private items inside child modules. Okay, but items in child modules can use the items in their ancestor modules. This is because child modules wrap and hide their implementation details. But the child modules can see the context in which they are defined. To continue with our metaphor, think of the privacy rules as being like the back office of a restaurant. What goes on in there is private to restaurant customers, but office managers can see and do everything in the restaurant they operate. What goes on in there is private to restaurant customers, but office managers can see and do everything in the restaurant they operate. Rust chose to have the module system function this way so that hiding inner implementation details is the default. That way, you know which parts of the inner code you can change without breaking outer code. However, Rust does give you the option to expose inner parts of child modules code to outer ancestor modules by using the pub keyword to make an item public. Rust chose to have the module system function. Rust chose to have the module system function this way so that hiding inner implementation details is the default. That way, you know which parts of the inner code you can change without breaking outer code. You know which parts of the inner code you can change without breaking outer code. However, Rust does give you the option to expose the inner parts of child modules code to outer ancestor modules by using the pub keyword to make an item public. Exposing passes with the pub keyword. Let's return to the error. Let's return to the error in listing 7-4 that told us hosting module is private. We want the eat at restaurant function in the parent module to have access to the add to waitlist function in the child module. So we mark the hosting module with the pub keyword. It is shown in listing 7-5. So listing 7-5, declaring the hosting module as a pub to use it from eat at restaurant. Declaring the hosting modules as pub. We pub to use it. Okay. Declaring the hosting module as a pub. Okay, to use it from it at restaurant. Okay, makes sense. Yep. So unfortunately, the code in listing 7-5 still results in an error. Okay, private function. What happened? Adding the pub keyword in front of mode hosting makes the module public. With this change, if we can access front of house, we can access hosting, but the contents of hosting are still private. Making the module public doesn't make its contents public. Makes sense. Okay. Oh, so pub. Okay. Makes sense. Okay. Okay. The pub keyword on a module only lets code in its ancestor modules refer to it, not access to its inner code. Because modules are containers, there's not much we can do by only making the module public. Because modules store containers, there's not much we can do only making the module public. We need to go further and choose to make one or more of the items within the module public as well. The error in listing 7-6 say that the add to waitlist function is private. The privacy rules apply to structures, enum functions, and methods as well as modules. Let's also make the add to waitlist function public by adding the pub keyword before its definition, as in listing 7-7. Front of house, pub, okay, makes sense. Now the code will compile. To see why adding the pub keyword lets us use these paths and add to waitlist with respect to the privacy rules. Let's look at the absolute and related passes. In the absolute pass, we start with the crate, the root of our crate's module tree. Now the code will compile to see why adding the pub keyword lets us use these passes and add to waitlist with respect to the privacy rules. Let's look at the absolute and the related passes. Now the code will compile to see why adding the pub keyword lets us use these passes and add to waitlist with respect to the privacy rules. Let's look at the absolute and the related passes. Wait a second. Now the code will compile to see why adding the pub keyword lets us with respect to the privacy rules. Let's look at the absolute. Okay. In the absolute passes, we start with the crate, the root of our crate module tree. We start with the crate. Okay. The root of our crate is module tree. The front of a house module is defined in the crate root. The front of a house module is defined in the crate root. Yep. While front of a house isn't public because the eat at restaurant function is defined in the same module as the front of house. That is eat at restaurant, and front of house are siblings. Siblings. Siblings, we can refer to front of a house from either restaurant. Next is the hosting module marked with the pub. We can access the parent module of hosting. Next is the hosting module marked with the pub. Next is the hosting module. Okay. Hosting module marked with the pub. We can access the parent module of hosting, so we can access the hosting. Finally, the add to waitlist function is marked with the pub, and we can access its parent module, so this function call works. In the related pass, the logic is the same as the absolute pass, except for the first step. In the related pass, the logic is the same as the absolute pass. In the related pass, the logic is the same as the absolute pass, except for the first step. So, the front, rather than starting from the crate root, the passes start from front of a house. The front of a house module is defined within the same module as eat at restaurant. So the related pass starting from the module in which eat at restaurant is defined works. Then because hosting and add to waitlist are marked with the pub, the rest of the pass works, and this function call is valid. If you plan on sharing your library crate so other projects can use your code, your public API is your contract with the users of your crate that determines how they can interact with your code. There are many considerations around managing changes to your public API to make it easier for people to depend on your crate. These considerations are out of the scope of this book. If you are interested in this topic, see the Rust API guidelines. If you plan on sharing your library crate, so other projects can use your code. If you plan on sharing your library crate so other projects can use your code, your public API is your contract with the users of your crate that determines how they can interact with your code. There are many considerations around managing changes to your public API to make it easier for people to depend on your crate. These considerations are out of the scope of this book. If you are interested in this topic, see the Rust API guidelines. Best practices for packages with the binary and a library. Best practice for packages with a binary and library. Okay, we mentioned the package can contain both src main.rs binary create root as well as src lib.rs library create root. And both crates will have the package name by default. Typically, packages with this pattern of containing both a library and a binary crate will have just enough code in the binary crate to start an executable that calls code with the library crate. This lets other projects benefit from the most functionality that the package provides, because the library crate's code can be shared. We mentioned the package can contain both sets of packages, and both crates will have the package name by default. Both crates will have the package name by default. Okay. Typically, packages with this pattern of containing both a library and binary crate will have just enough code in the binary crate to start an executable that calls code data the binary crate. A binary crate will have just enough code in the binary crate to start an executable that calls code with the binary crate. Binary crate will show enough code in the binary crate to start an executable. This lets other projects benefit from the most functionality that the package provides, because the library create's code can be shared. The module tree should be defined in src lib.rs. The module tree should be defined in src lib.rs. Okay, then any public items can be used in the binary crate by starting passes with the name of the package. The binary crate becomes a user of the library crate, just like a completely external crate would use the library crate. It can only use the public API. This helps you design a good API. Not only are you the author, you're also a client. In chapter 12, we will demonstrate the organizational practice with a command line program that will contain both a binary crate and library crate. In chapter 12, we will demonstrate this organizational practice with a command line program. In chapter 12, we will demonstrate this organizational practice. In chapter 12, we will demonstrate this organizational practice with a command line program. In chapter 12, we will demonstrate this organizational practice. In chapter 12, we will demonstrate this organizational practice. In chapter 12, we will demonstrate this organizational practice. Chapter 12, we will demonstrate. In chapter 12, we will demonstrate this organizational practice. In chapter 12, we will demonstrate this organizational practice with a command line program that will contain both a binary crate and library crate. Okay, makes sense. Start. What is the keyword you use at the start of an absolute pass crate? Determine whether the program will pass the compiler. If it passes, say that will happen. Okay, faster run. Okay, so foo, this is so like a related pass. So foo bar b foo, public foo, and bar is not a public, it's a private. So it's impossible to access this. Blocked. Does not compile. Select line here 9. Foo a related pass. Okay, foo and then a foo. It works. And then it will be which oh shit bar b which second what? Okay, bar later pass bar to b to b. Yes, yes, yes. Ah shit. Starting lady passes with a starting lady passes with super. We can construct the lady passes that begin in the parent module. We can construct the lady passes. We can construct lady passes that begin in the parent module. Construct the lady passes begin in the parent module rather than the current module or the create root. By using super at the start of the path, this is like starting a file system path with the data syntax. Using super allows us to reference an item that we know is in the parent module. Allows us to reference an item that we know is in the parent module, okay, which can make rearranging the module tree easier when the module is closely related to the parent. But the parent might be moved elsewhere in the module tree someday. Consider the code in listing 7-8 that models the situation in which a chef fixes an incorrect order and personally brings it out to the customer. The function fix incorrect order defined in the back of house module calls a function deliver order defined in the parent module by specifying the path to deliver order starting with super. Consider the code in listing 7-8. Consider the code in listing 7-8. Consider the code in listing 7-8 modules in the situation in which a chef fixes in an incorrect order and personally brings it out to the customer. The function fixing correct order defined in the back of house module calls the function deliver order, defined in the parent module by specifying the path to deliver order, starting with super. Deliver order and then mode back of house in fixing correct order, cook order, super deliver order. So it's parent, okay, makes sense. So the fixing correct order function here this one is in the back of house module. Yes, so we can use super to go to the parent module of a back of house. Yeah. Which in this case is a create the root. From there, we look for deliver order and find it. Success. We think the back of a house module and the deliver order function are likely to stay in the same relationship to each other and get moved together should we decide to recognize the create module tree. Therefore, we need super. We use support, so we will have fewer places to update code in the future if this code gets moved to a different module. Super, and then put super here. Fix incorrect order. Cook order. Deliver order. Anyway, making structures and enum public. We can also use pub to designate structures and enums as public. We can also use pub to designate structures and enums as public. But there are a few details extra to the usage of pub with the structures and enums. If we use pub before struct definition, we need the struct public, but the struct's field will still be private. We can make each field public or not on a case-by-case basis. In listing 7-9, we will define the public back of a house. We will define the back of a house. Okay. And then breakfast. Okay, so breakfast. Structure with the public toast. Public toast field but a private seasonal fruit field. This models the case in a restaurant where this customer can pick the type of bread that comes with the meal, but the chef decides which fruit accompanies but the chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers cannot choose the fruit or even see which fruit they will get. But the chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers cannot choose the fruit or even see which fruit they will get. The available fruit changes quickly, so customers cannot choose the fruit or even see which fruit they will get. But private seasonal fruit, this models the case in a restaurant where the customer can pick the type of bread that comes with the meal. But the chef decides which fruit accompanies the meal based on what's in season and in stock. The available fruit changes quickly, so customers cannot choose the fruit or even see which fruit they will get. Makes sense. Because the toast field in the back of a house breakfast structure is public in it at restaurant, we can write and read to the toast field using dot notation. Makes sense. Breakfast, meal, back of house, breakfast, and then summer meal, summary. So re goes into this and then returns. Okay, makes sense. Makes sense. Okay. Because the toast field in the back of us is constructed for public in a restaurant, we can write and read to the toast field using a notation. Notice that we cannot use the seasonal fruit field in either restaurant because the seasonal fruit is private. Try uncommenting the line modifying the seasonal fruit field value to see what error you get. Notice that we can't use the seasonal fruit field in a restaurant because the seasonal fruit is private. Try uncommenting the line modifying the seasonal fruit field value to see what error you get. Makes sense. Also note that because back of house breakfast has a private field, the structure needs to provide a public associated. Also note that because back of house breakfast has a private field. Also note that because back of house breakfast has a private field. Also note that because back of house breakfast. Also note that because back of house breakfast. Because back of house breakfast has a private field. Also note that because back of house. Also note that because back of house breakfast. Breakfast truck is public. Breakfast has a private field. Yes. field. The structure needs to provide a public associated function that constructs an instance of a breakfast. What? Commenting the line the structure also note that because you back of a house breakfast as a private field, the structure needs to provide a public associated function. That constructs an instance of breakfast. If breakfast didn't have such a function, we couldn't create an instance of breakfast in it at restaurant. Because we couldn't set the value of the private seat and private field in a restaurant. Makes sense, okay. Okay. So that's the way, okay. In contrast to if we make an enum public, all of its variants are then public. We only need the pub before the enum keyword. This is the difference between structure and yes. Because we made the appetizer enum public, we can use the soup and sell the variants in it at restaurant. Enums aren't very useful unless the variants are public. It would be annoying to have to annotate all enum variants with a pub in every case. So the default for enum variants is to be public. Structures are often useful without their fields being public. Structures are often useful without their fields being public. So structure fields follow the general rule of everything being private by default, unless annotated with pub. Yes. There's one more situation involving pub that we haven't covered. There's one more situation involving pub. Oh, there's one more situation. There is one more situation involving pub. Okay. That we haven't covered, then that is our last module system feature, the use keyword. We will cover use by itself first, and then we will show how to combine pub and use. Use keyword, okay. Determine whether program will pass, okay. Wow, what the fuck is this? Okay, so create entry, create a, and then here entry, and then super is B. So super B, okay, and then C, super B, and then C, and then F, and then this will print C2, definitely. Derivative, what the fuck? Oh, okay, to use this. Let P point. So this is related path, okay. Point, origin. Wait a second, what? Point, origin. Self. Point. By default, the fields will be private because it's a struct. So that you should have a self and then return it. Makes sense. And then 0.00. Yep, makes sense. Then trying to access the field, which is private. Then it does not compile, and then it will throw an error here at 12. Yes! Got it.